All right, today we are going to talk about 6.2, and the essential question is how do the rules of exponents help us simplify radical expressions? So we're going to just quickly review some of the exponent rules. If you have x to the m power times x to the n, all you do is add the exponents. If you're dividing exponents with the same base, you just subtract them. And for the power to a power rule, you would multiply them. With negative exponents, that's where you want to cross the line, change the sign. So you can think about it as being over the number 1. X to the negative m will become x to the positive m when it moves to the denominator, and then you would write 1 over x to the power of m. 0 is an exponent rule. Anytime you see a 0 in the exponent, it automatically equals 1. And fractions with exponents. All you have to do is distribute the exponent, but be careful, you need to distribute to both the numerator and the denominator. So let's practice. We have 16 to the 2/3 times 16 to the 1/3. The difficult part here will be the fractions. You just have to get a common denominator and add. So I'll do a little bit of side work. 2/3, 1/4. They're going to have a common denominator of 12. So this is the same thing, as 16 to the 11 over 12 power. And you can simplify this just a little bit more because we could rewrite 16 as 2 to the 4th power. Oops, not 24, 2 to the 4th power. And then we can multiply because we're taking a power to a power. So 4 over 1 times 11 over 12 becomes 11/3. And then this final answer would be 2 to the 11/3. You could write it in radical form, but for now that's perfectly fine if we leave it how it is. For 16 to the 1/4 power, again, we're taking an exponent to an exponent. So you can distribute the 3 and multiply. 3 over 4 times 3 over 1 is the same as 9/4. And you can even simplify this one a little bit further because we could rewrite this as the 4th root of 16 to the 9th power. The 4th root of 16 can be simplified to 2 because if you take 2 times 2 times 2 times 2, that equals 16. And then this final simplified expression becomes 2 to the 9th power. And if you type that in on your calculator, the exponent key is directly above the division symbol, so you would type 2, and then exponent, and then 9. And then you can hit enter. 512. can look at one more on this slide. And again, it might help to keep in mind that so far we have been substituting this, this base of 16 with 2 to the 4th, because that can help make our algebra just a little bit easier. So for 16 to the 5th power, again, I'm not going to write 16. I'm going to write the base as 2 to the 4th power. And then raise that to the 5th power. I'm going to do the same thing to the denominator. I'm not going to write 16. I'm going to write 2 to the 4th power. And then raise that to the 3/4 power. And then the reason for that, I'll do a little bit more side work. If I take 4 times 3/4, or 4 over 1 times 3/4, your 4's cancel. And then this becomes 2 to the 3rd for the denominator. And in the numerator, we're taking a power to a power, so you would just multiply. Now we have exponents that have the same base. They're all those integer numbers. All we have to do is subtract 20 minus 3, and then we should be getting 2 to the 17th power. And that's another one that you can type into your calculator. 2 raised to the 17th. And we get 131,072. Okay, so knowing some of these bases can help make the algebra steps a little bit easier, like what we just saw. We didn't have to worry about subtracting 5 minus 3/4. I think it's a lot easier to just multiply 3/4 and 4 than it is to subtract 5 minus 3/4. So keep some of those tricks in mind as you're working through these questions. Okay. So a couple more simplification questions. Again, we're taking a power to a power, so you want to take the exponent and distribute. The most common mistake that I see is people will rewrite this, they'll distribute, they'll multiply, they'll say 4 times a to the 8th power times b to the 12th. There is a sneaky 1 that you can't see right behind the 4th power. So you also have to remember to distribute the 4, the exponent 4 to the 4 to the power of 1. So this is the same thing as 4 to the 4th power, and then a to the 8th, and b to the 12th. And again, for 4 to the 4th power, you can grab the calculator, type it in, 256. You also could have rewritten that as 4 squared squared. 16 squared is also 256. Again, with those little algebra shortcuts. Okay. And then for this second example, we have 4 over 9 all raised to the 1/2 power. So you can rewrite the bases because those are both squares. So you can rewrite this as 2 squared over 3 squared, all raised to the 1/2 power. Distribute and multiply. Two times 1/2 is just 1. 3 times 1/2, or sorry, 2 times 1/2 again is still just 1. So this just becomes 2/3. Second option, if you like this better, this is the same as the square root of 4 over 9, which is the square root of 4, over square root of 9. Two ways of getting to the same answer. Okay, so we've talked about multiplying radicals before. This is the same idea with any root number. So we're taking the third root of a times the third root of b. You can combine this underneath one radicand symbol. So this becomes 3, or the third root of a times b. And you can't do anything else with that because there are no other variables, numbers, anything like that. So similar to what we talked about when we were combining, simplifying radicals with the square roots, we would write out a factor list and we'd say this factor is a perfect square. Here's what's left over. Write it underneath the radical symbol and simplify the perfect square. It's the same process here, except for we're looking for a perfect cube instead of a perfect square now. And I'm not super familiar with all the cubes, but what I do know is that my calculator knows how to figure all this out. So we're looking for two numbers that multiply to make 135. One of them has to be a perfect cube. You can have your calculator do this by creating a table. Y equals, basically we're taking two numbers and multiplying them together, right? X times y equals 135. So we're going to rewrite that. We're going to rewrite this as y equals 135 divided by x. And then instead of just hitting graph, I'm going to hit y equals and table. And then I get a whole table of values. We shouldn't have a value at 0 because we can't divide by 0. But you can scroll and see that 1 times 135 makes 135. 3 times 45 is another pair that works. And then keep scrolling down until you see a factor pair that works. And it has a perfect cube. So for us, I see 5 and I see 27. The cube root of 27 is 3, so that's the pair that we want to use. I'm going to move the perfect cube to the front because I can write this in whatever order I want. And that simplifies to become 3 cube root 5. And if you don't like having the calculator do it and you'd rather just multiply it out and see what makes 135, you certainly can do that. I think it's a little bit quicker if you use the table in the calculator. So the next one we're going to simplify is the fourth root of 112. So again, we want to look for two numbers that multiply to make 112, but one of them has to be a perfect cube. So all I changed is the number that I'm dividing by x. I'm pulling up the table. And I want to look for a perfect cube, or sorry, not a perfect cube, something that I can take to the fourth power, or take the fourth root of. And I found that here with 7 and 16. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 equals 16. So we're going to do the fourth root of 7 times 16. Which can be written, and I'm going to switch the order so that the rational number will go first. And this simplifies to 2 fourth root 7. All right, we're just going to look at a few more examples for part 2.